To help you understand what the permutation is. So the definition of the permutation is a one-to-one function from a set to itself. So for example, how many numbers can you choose? How many three-digit numbers can you make with just 1 and 2, right? Right? So, well, how many, yeah, three-digit numbers with just 1 and 2. Right? You can have 1, 1, 1, you can have 1, 2, 1, you can have 1, 1, 2, you can have 2, 1, 1, and 2, 2, 1, or 2, 2, 2, right? So 6 of them, right? So in this time, the order matters, right? The order, even though you're using two ones and 1, 2, 1 to 121 and 112 are different, so the order matters. So that's what we call permutation. So the notation looks something like this. P, and you get small 6 on the left bottom and 3 on the right bottom. And we call this is the total number of permutation of 3 objects taken from a group of 6. So 6 is a group of 6. 3 is the object. So this stands for, so think about how many different ways to put 3 objects in a group of 6. So you can pick 3 items, so that means you have 3 slots. How many choices do you have to fill in for the first box? You have 6 of them. Once you pick that one, once you pick 1 out of 6, for the second box we only have 5 choices, and then the next one we only have 4 choices. So permutation of 3 objects taken from a group of 6 is 6 times 5 times 4, which is 120 different ways. Okay. So let's generalize it. So if you think about permutation out of n object, a group of n, permutation of k object taken from n groups of n, right? This means that you're going to start it out with whatever number of the group of, and then you multiply by 1 less than the number, and then you multiply by 2 less than that number, and so on and so forth, until you have k objects. So you have 1, 2, 3, 4, 5, 6, 7, and you multiply k object. Right? So, if you think about the permutation of, let's say, 4 objects taken from 7 groups of 7, right? That's going to be 7 times 6 times 5 times 4, right? Because you have 4 objects, 1, 2, 3, 4, and out of group of 7, right? So this is equal to 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by this guy, right? Right? So 3 times 2 times 1, right? So that's going to cancel out, right? So that means this is equal to 7 factorial over 3 factorial, right? So if you look at it, that 3 comes from 7 minus 4, right? That 7 factorial comes from this guy. So if we have P permutation of k object taken from group of n, means that you have n factorial on the top all over 7 minus 4, in other words, n minus k. So n minus k factorial. You see that? But how do you know this is equal to n times n minus 1 times n minus 2 dot 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 n minus k plus 1. So let's look at it. So let's start it out with, I need more space. Let's start it out with n factorial over n minus k factorial, right? So that means we have n times 1 less than n times 2 less than n times dot dot dot, and you'll have n minus k plus 1 and n minus k and n minus, I need more space, right? Just do it again. That equals n times n minus 1 times n minus 2 dot dot dot, and then you ended up hitting n minus k, which in our previous case it's 3 because 7 minus 4 is 3. But before that we'll have n minus k plus 1, right? One more than a number, right? And then you got n minus k, and then you have 1 less than n minus k, so just keep going and going. At the end we'll have 2 times 1. Is that okay? Now, that divided by n minus k factorial. So you get n minus k, you start out with that, and then you multiply by 1 less than whatever the number is. So I subtract 1. And then you have 2 less than that, and so on and so forth, and at the end you get 2 times 1. And if you look at this one, this guy n minus k down on the top, or the numerator, and the 1 on the bottom are exactly the same. And so whatever that one divided by the same thing should be 1, so that should cancel out, and what's left will be n times n minus 1 times n minus 2 times n minus 3, and so on and so forth, and at the end you should have n minus k plus 1. Okay. Also, it is important to notice that 0 factorial equals 1, right? Why? Well, what does it mean by 0 factorial, right? 0 factorial, this is something that mathematician has to come up with, you know. Okay, we cannot compute 0 factorial. So, because what do you mean by picking 0 object from a set of, but picking 0 object from a set makes sense, right? So you have a group, so let's say you have 5 baseball cards, right? How many different ways not to pick anything? It's one way, right? One way is that to pick nothing. Pick nothing is still one way of picking, right? Right. So we say 0 factorial equals 1, and that's going to make sense of the computations and everything. So 0 factorial is not equal to 0. It is 1.